whenever we have a rational exponent, what does that mean? So, for example, x to 1/3. What does this mean, really? Very good, indeed. It is the cube root of x. Excellent. So, which of these two powers is smaller? Is it the 1/3 or the 2/3? It's a silly question, right? It's 1/3. So, I'm going to say, what if I denote this by t? So, x to 1/3. This procedure, which I'm hoping that is quadratic in form, works only if this can be replaced by, yes, if this is not t squared, then I will have to draw the conclusion that the equation is not quadratic in form, and I cannot apply this procedure. But is it? So if I square x to 1/3, I copy the base, and what do I do with the exponents? Correct. 1/3 times 2/1 is 2/3. So indeed, this is t squared. So now the new equation becomes, so now no one will force you to use a particular method. You can say, I know 4 methods. Of course, I'm not going to use completing the square. I cannot, as is, I cannot take square roots. So I have 2 options, either quadratic formula or factor. You can say factoring may take more than 20 seconds, then forget it. Let's use a quadratic formula. It doesn't matter. No one is forcing you now to use a particular method. So then I have negative b plus or minus b squared minus 4ac, 4 times 4. Instead of writing -7, I'm going to change the negative into positive over 2 times a. Right, only because I don't want to put parentheses and parentheses and parentheses if I can avoid it. So one more time. Negative b plus or minus b squared minus 4 times 4 times -7, but I have a minus from the formula and I have a minus from c. So I change it into positive. And this is what I recommend to you to do. Don't forget to put parentheses around the numerator. So in parentheses, 27 plus the square root, parentheses again, 27 squared. Stop me if you have any questions anytime. Plus 4 times 4, I'm going to write 16 times 7. Close the parenthesis under the square root. Go outside and divide by 8. And then copy with second and entry. You don't have to do this. I want to do it so that I don't have to type it in again, but you don't have to if you don't want to. So second key and entry. I can show it again if you need to, if you need me to. So then I just go back and override the positive, change the positive into a negative. And I press enter. And I know that this is -1/4. But this is not done. These are just the 2 values for what? For t, indeed. So these are the values for t. Any questions on how we got these 2? Is this okay? Everyone? Any questions? Okay. So then I will write t equals 7 and t equals -1/4. But now these are 2 more equations that I need to solve. Which equations can anyone dictate? What is t equals 7? The left-hand side is the, very good, or the cube root, the same thing. Excellent. And then the other one is the cube root of x equals -1/4. You can keep it as x to 1/3, the same thing. So what do we do to both sides of these 2 equations in order to get x? Because x is what we're solving for, not t. How do I eliminate power 1/3 or the cube root? Very good. Raising both sides to the 3rd power. So this is x equals 7 to the 3rd. How much is 7 to the 3rd? 343. And then the same thing again with x equals -1 over 64. Yes, I have to go back and check in the original problem. However, because we raised it to an odd power, all solutions will work. But we should go back and check. Sissy, is this okay? Is this good enough? Did you have anything else? Anyone else? Other questions for me? Anything? Anything? Okay, so let's finish chapter 1 then. 1.7, linear and absolute value inequalities. Okay, linear should be pretty straightforward. So let's look at an example. Let's say 40 on page 203, in which we have 5, 3 minus x less than or equal to 3x minus 1. This is a linear inequality. It doesn't have anything else, just power 1 for the variable, so it must be linear. What is the first step? Can anyone refresh our memory? Of course, indeed. 15 minus 5x less than or equal to 3x minus 1. I recommend keeping the variable on the left. However, it's not mandatory. But if you keep the variable on the left, you will, I think, not make a mistake when you write the solution in interval notation. I'll explain in a minute. So I will move 3x and I will move 15. When I move 3x, which was positive, to the other side, it becomes negative. So negative 8x less than or equal to. When I move 15 to the other side, it becomes negative. So negative 16. Obviously, at this point, I will have to divide both sides by negative 8. What do I get on the left-hand side? I get x, very good, and on the other side, I get 2. But now I have to think. Whenever we divide or multiply both sides of an inequality by a negative number, what do we need to do? Correct. And here's why. Here's just a simple example why. Is 2 less than 4? Yes. So let's multiply both sides for whatever reason. We shouldn't, but let's, for the sake of the argument, let's say I'm multiplying both sides by negative 1. Can I still keep the same inequality symbol? No, because negative 2 is not smaller than negative 4, but it's the other way around. So every time we multiply or divide both sides of an inequality by a negative number, only negative, we have to switch the symbol. So the same thing here, from less than or equal to greater than or equal to. So now in interval notation, I hope we don't have to graph them all the time, but that's okay if we do for a few. And if you want for the other ones, moving forward, it doesn't matter. So I read x greater than or equal to 2. 0 in the middle, negative infinity and infinity. So 2 is somewhere here. I don't care for units. Greater than, I use a bracket. Or full point. I don't prefer the full point. It's up to you. You can use either one. But this is the interval notation. Bracket when we have the equal symbol. Infinities are always parentheses. So in interval notation, 2, comma, infinity. Any questions on this? Any questions? Okay. Do you think we need another linear inequality before we move on? Let's look at 46 on the same page 203. And then we can look at absolute value inequalities. 4x minus 3 divided by 6 plus 2 greater equal to 2x minus 1 divided by 12. So one other reason why I would like you to redo the problems we do in class, sometimes I do choose from the problems I solve in class, And sometimes I always choose similar examples with the ones that we do in class. So always, please, redo the problems we do in class as many times as you need. Okay, so now we could say, okay, this problem is more difficult because it has fractions. However, it's not a big deal. I can eliminate fractions in a blink. So how will you do that?
Least common.
Which is? That's the greatest common factor, so not to be confused with the least common denominator or the least common multiple. Do we know the difference between the greatest common factor and the least common denominator?
Can you just say?
Sure. So here I see three denominators, 6, 1, and 12. For now, of course, I can omit 12. So 6 and 12 have a greatest common factor of 6. 6 being the biggest number that both numbers are divisible by. But the least common denominator, or the least common multiple of these two, so of 6 and 12, I should say, is 6. So the least common multiple of 6 and 12 is 12. So 12 is the smallest number that is divisible by 6 and 12. This one is the largest number that goes into 6 and 12. This one is the smallest number that is divisible by 6 and 12. You can say, what about 24? But that's not the smallest number that is divisible by 6 and 12. 24 is good, but it's not the smallest. So 12 is the least common denominator, and we will multiply everything by 12, everything, the fractions by 12 over 1, this one just by 12. There is no need to put it over 1. So then, we always simplify before we multiply. 6 divided by 6, 12 divided by 6. 12 divided by 12, 12 divided by 12. So what we have coming from the first product, what will you write from the first product? Awesome. Plus, thank you. What will you write from the second one?
24.
Plus 24, greater than or equal to. And what will you write from the last one? What is left from the last one?
2x minus 1.
Good. So now, although at first we said, oh, fractions, but we got rid of them very quickly. So now, combine like terms first before you start moving terms around. Stop me if you have questions, please. Yes?
How did you get the 8x? How?
2 times 4x, 2 times negative 3.
12 times 4x.
2 times 4x, 2 times negative 3. I simplified first. I don't want to distribute and then simplify. It's always easier to simplify first and then distribute. So then we have 8x plus 18 greater or equal to 2x minus 1. And now we're back to the first situation in which I move 2x and I move 18. So this is 6x greater or equal to negative 19. So we subtract 2x or move 2x from one side to the other and move 18 from the right, which is positive, from the left, which is positive, to the right, which is negative. Since at this point we are dividing both sides by a positive number, which is 6, we do not switch this symbol. But in interval notation, what will you write? And I like to write x is found in the interval. Which interval would you write? We can graph it if that's better for you. But if you read the inequality, you will know where to start. Yes, because it's greater than. But what do I put here? Bracket or parenthesis? Yes, because of the equal symbol, I have to use a bracket. And infinities are always parentheses. Any questions on linear inequalities? Any questions on linear inequalities?
Yeah. I have a question.
Okay.
When do you change the sign?
When we divide or multiply by a negative number.
Okay.
We only divided by 6, so we did not change the sign in this case.
Okay. So only when multiplying or dividing by negative.
By negative numbers only. The last topic of this chapter, absolute value, inequalities. Let's start with very simple examples. Discuss those, and then we look at more sophisticated type of absolute value inequalities. What does the absolute value of 3 represent? Forget about 3, I don't want to confuse you, I'm not looking at this 3. The absolute value of 10, what is it? It's the distance between 0 and 10. It's a distance. The absolute value is a distance. Agreed? What is the absolute value of negative 5? 5, because it's the distance between negative 5 and 0. Okay, what does the first inequality say? Here's what the first inequality says to me. Find x values, whatever they are, wherever you will find them, it doesn't matter to me, but just find those x values, whose distance from 0 is 3 units or less. 3 units or less. 3 units or less. How many numbers are exactly 3 units away from 0?
6.
3 units
3.
away from 0.
3 or negative.
I want them to be closer to 0. They have a smaller absolute value, smaller distance from 0. So where will I find those numbers?
In between.
Exactly, that's all I needed to know. In between. That's all I wanted. So can anyone express this? Because we cannot solve it. Don't cross it out like that. I'm making a point. So what will you say? X must be in between That's it. In interval notation, -3 to 3. X in the interval. So on the real line, the solutions of the first inequality, again, you know I don't care for units because that's not the point here. So here they are. So whenever I have to solve an absolute value less than a number, I am looking at in between. In between. So now let's solve the other one. The other one is this. What does this say? And you understand it cannot say in between. Is that clear? The in between is already taken, right? Good. So let's see what that says. That says this. Find numbers x whose distance from 0 is 3 units or more. Not 3 units or less. 3 units or more. So, where will I find these solutions then?
0 and up.
0 and up includes in between? I can't. This is already taken. Very good. So x greater than or equal to 3, which will be this territory, or which translates with the symbol of union, or where else? Where else will I find numbers whose distance from 0 more than 3 units? X to the, how do I express this with an inequality? Very good. Less than what?
-3.
Indeed. So it's this piece as well. So this has these solutions. And how do I write it? X in the interval, exactly what I see, between negative and -3, union 3 to infinity.
Why is the negative 3 again? 2 from negative 3?
3 units or less. 3 units or less.
Okay. Oh, less
3
than
to the right, negative 3 to the left.
Gotcha.
So what do I need to remember? I need to remember that when absolute value is less than, it's in between. When the absolute value is greater than, it's outside. And do not separate these two inequalities as the way we separated these two. Do not do that. There is no such thing in any book. Whoever teaches that, I think it's wrong. You may forget to intersect. So do not do that. So this is the easy one, chain. This is the more complicated one because I have to look into two different situations. And they will be put together with a union symbol. Okay, this is the theory. And now let's look at situations here. Let's start with 66 on page 203. And the absolute value of 3x minus 1 plus 2 in absolute value less than or equal to 20. We need to write a note. The absolute value is not a grouping symbol. Please do not put stuff in, distribute stuff in, factors in. Do not take anything outside. You cannot do that. Can I simplify inside? Yes, and I will. The absolute value of 3x minus 3 plus 2 is less than or equal to 20. Always remember, two key words here. Simplify, factor if we need to, if it helps. So now inside we have 3x minus 1. So the absolute value of 3x minus 1 less than or equal to 20. No one can touch this. Again, untouchable. Do not try to distribute or take something outside or say, oh, I can drop the absolute value symbol. No, it's not a grouping symbol. So from here, if we don't know, do not cross it out like that. I'm making a point. You can't touch that. You can only replace it by what it equals to, or something that will give us the solutions, but you cannot touch that. So how do I convert this, and what do I convert it into? We cannot change the inequality symbol into an equal symbol ever. It's okay? So then what do I write? My question is it in between or is it the outside? If it's in between, then you have to give me two numbers here and here. That's it. So that's the easy one. It's the in between. After you completely simplify it, you change this inequality with absolute value into this, because this you cannot solve. But this we can. This is a compound inequality. What is the first step?
Take 1 from
Very good.
sides.
Add 1 to all three sides. Very good. Negative 19 less than or equal to 3x less than or equal to 21. Excellent. Perfect step. Final step.
Then take it apart and make 3x equal to both. So 3x
We can never take it
not
apart.
take it
It's
apart.
the one that it's a chain. We will not do that.
divided by 3.
Awesome. That's all I needed. Thank you very much. So we have negative 19 thirds less than or equal to x less than or equal to 7. The interval notation is exactly what you see. X in the interval. Can anyone give us the interval with the correct symbols? Very good. Bracket. Negative 19 thirds from left to right, comma.
7.
Excellent, with a bracket. Perfect. This is it. Let's look at 80. 5, the absolute value of 2x plus 1 minus 3 greater than or equal to 9. I'm making a point. Do not cross out anything. I'm just saying do not even look here. You cannot touch that. You cannot remove anything. You cannot put anything inside, nothing. But there are many other things that we can do before we think of what it is and how we apply and what we apply and so on and so forth. So what will be the first step?
Add 3.
Of course, thank you very much. 5, the absolute value of 2x plus 1 greater than or equal to 12. Excellent. Because we always clean up and simplify everything we are given to solve, work on, whatever. So what will be the next step then? Of course. Only now when it's completely cleaned up, again, don't even look at 2x plus 1 in absolute value. You cannot touch that. And you cannot touch the whole thing. Untouchable. But we know that it converts into something we can touch and we can solve. What does it convert into?
2x, no, well, hold on. Because it's greater than or equal to.
Good.
So, let me write this out first. Equal to 12.
We still have 2x plus 1. That's correct. And then
Is greater than negative, not negative, 12 over 5.
greater than or equal to 12 over 5, indeed. And 2x plus 1 less than or equal to. Very good. So it's the outside, nothing inside. You cannot include anything between negative 12/5 to 12/5. That's not allowed. You can include to the right of 12/5, and you can include, or you can include to the left of negative 12/5. Very good. Now this we can solve. Solving this is solving this. But this I can't if I don't know how to convert it. So then, next step. I have 2x plus 1 greater than or equal to 12/5. And then I'll solve the other one. You can eliminate fractions if you want to. You can move 1 to the other side and then divide by 2, whatever you want to do. Which method you would like to apply? You want to eliminate 5 first? Okay, fine. So let's multiply everything by 5. So 10x plus 5 greater than or equal to 12. And then you will move 5, correct? So 10x greater than or equal to 7. And then you have x greater than or equal to 7 over 10. Any questions on this?
Can you
Yes.
go back on how you got that again? No,
Which part?
the 2x plus 1.
This one?
No, down here.
2x times 5, 1 times 5, 12 over 5 times 5. Was that the question, Susie?
Yeah, no.
Yes? Okay. And then I subtract 5, and I get 7, and divide by 10. So in the same way, we have 2x plus 1 less than or equal to negative 12/5. I'll do the same thing. 10x plus 5 less than or equal to negative 12. So now 10x less than or equal to negative 17, and x less than or equal to negative 17/10. Everything was the same, but it's just that we had a less than and a negative number on the other side. We multiplied both sides by 5 and subtracted 5. So now the solution, I know this is the most difficult of the two. I know the solution must have the union in between. And I know that it has to start at negative infinity till something, union something to positive infinity. So I know that. And I'm going to write x is found in this interval. So which one goes in first? From negative infinity till?
Negative 17.
Of course, because that's smaller. Very good. And? But that was less than. So it's here. Okay. Yes. 7 over 10. This is it. So less than was here, greater than is here. Is that okay? Everyone, is this okay? Do you think we need more examples?
Can we just do one?
Yes. From which one? Which type? The second one. Very good. So let's take a look at 76. Same page. 203. The absolute value of 3x minus 3 over 9 is greater than or equal to 1. There is nothing I can do here. It's already cleaned up. But I have to identify which type it is. Is it type 1, the nice one with a chain, or is it the most difficult one, but the more difficult of the two? The one in which I have two separate inequalities, and one is less than, and the other one greater than. Right, it is the difficult one. So then, remember, you cannot touch anything. Do not try to eliminate the denominator. You don't. If you multiply both sides by 9, I can't give any credit. So remember, you cannot touch this, but you can write two inequalities that we need to solve. Once we solve these two inequalities, we are solving the original inequality with absolute value. So what do we do? Of course, 3x minus 3 over 9 and 3x minus 3 over 9. You don't have to tell me that. But what are the options? Well, you only have to remember in between or outside. You don't have to remember anything. Just these two concepts. In between, outside.
Well, it's greater or less than
Okay, very important.
outside.
That's okay, very important. If you write something like this, I cannot give any credit. If you write something like this, I cannot give any credit. You can only write this or this. If I see something like this, I can't have any credit. Because there is no such thing. And there is no such thing. It's either this or this. But not for this one, though. So, what do I write?
Greater than or equal to
Perfect.
1 and negative 1? Oh, no.
1. Good. So we're talking about to the right-hand side of 1. Good. And this one, which we're talking about less than or equal to the left-hand side of negative 1, union to the right-hand side of 1. Nothing in between. Is that clear?
No. Can you say that? What? Could you say that again?
So if this were less than or equal to 1, I would have written negative 1 to 1. But it's greater than or equal to 1, so I have to write to the left of negative 1, union to the right of 1. It's the outside. This is greater than or equal to 1. This is less than or equal to negative 1. Nothing in between. Better? So you only have to remember in between or outside. If it's outside, it's less than or equal to a negative number, or greater than or equal to a positive number. If it's in between, it will be between negative 1 and 1. Just two options. Does it make sense, first of all?
Yeah, that equation is that way. Or
Exactly, because this is greater than or equal to 1.
okay.
If it were less than, I would have written a chain like this. Negative 1, less than or equal to the inside, less than or equal to 1. But I cannot include that because it's greater than. Better? Okay, so of course the first one I'll multiply by 9, and I get 3x minus 3 greater than or equal to 9. And then 3x greater than or equal to 12, x greater than or equal to 4. I will repeat for the second one. 3x minus 3 less than or equal to negative 9. 3x less than or equal to negative 6, s less than or equal to negative 2. Let's take a moment and look at this. I don't want to be too fast. These are just linear inequalities. And I multiply both sides by 9 and added 3 to both sides.
So now we can do it by
Only now we're ready for the union. X in the interval. What goes in the first one? Excellent.
4.
That's it. Less than or equal to -2 is this. Greater than or equal to 4 is this.
What's the union sign for again?
I'm sorry?
What does the union sign state again?
Well, we can put together a piece from here and a piece from here. We have to use the union symbol. It says, actually, it's a very good question. What it means is, it says this. X values that solve this inequality can be found here or here. That's all it means. So the union symbol replaces the conjunction or. So if you're looking for solutions, you should be looking to the left-hand side of -2 or to the right of 4. You will find solutions. But if you look between -2 and 4, don't. There will not be solutions. Okay, any questions on this? Any questions? Okay, this is the end of chapter 1. So what I recommend for us to move forward as a team, I would like you to finish everything from 1.1 through 1.7, the sections that we covered. We didn't cover all sections, right? And the factoring supplement. Which factoring supplement? One more time. It's this one with 7 questions. So please redo the problems we did in class together. So one more time, is this supplement with 7 questions. So these questions have the final answer here. So please do all of them and check the answer. If you don't get the answer, please come back and maybe you want to come in early so we can go over this. Okay? So one more time, for those of you who just, I don't remember if I said it before some of you came in or not. So one more time, test 1, we have to finish section 2.5, and only then we schedule test 1. And test 2 is from these sections, and then we schedule test 2, and then test 3 is from these sections, and then we schedule test 3. Not before. I put in a calendar a tentative date, but of course I always fall behind. My apologies. Okay, so you also have a factoring in my math lab, a section of factoring in my math lab. So please finish that too. And the factoring supplement. Okay, everything is there. I'll show you. So also, the interim grade will come up soon. So we have to have a test before the interim grade is due. The interim grade is only an assessment of your work. You will not be part of your final letter grade. But I have to turn in an assessment of how you performed so far. Did you find it?
No, I don't think I have it.
It's this one.
It is this one?
Yes, it's this one, and those are the questions. Okay. Moving on to chapter 2.
And this needs to be done by Wednesday?
Yes, we did several of them in class. So please redo the problems we do in class. I know I sound like a broken record. I'm kindly asking you, and I don't mind begging you, please redo the problems we do in class. I select from those or similar to those to put on the test. So just doing your homework in my math lab is not good enough. So please redo the problems we do in class first, please. Okay, so in chapter 2, we're going to talk about functions. Chapter 2 is a very long, I shouldn't say very long, it's a long chapter. It has 8 sections. And however, 2 of those 8 should be super well known. It's okay, even if don't remember them, I'm going to cover everything in those sections as well. So let's start with 2.1 and 2.2. This is all about details about functions. Details about functions. What details? Anything that we can read from a graph. What a function means or is. Domain and range. If the function is increasing or decreasing. If the function is constant. If the function is symmetric. So details like these. So let's start with what I like to call bubbles, but they are called Venn diagrams. But let's look at 3 sets of bubbles. They're not connected. The sets are not connected. The individual bubbles are connected. So let's say 2, 4, and -3 in the first set of any set of bubbles, 2, 4, and -3. And give me 3 numbers for the other set. It doesn't matter what numbers you come up with.
6,
Okay, let's say 6, 0,
2,
5 is fine. Okay, 6, 0, and 5, 6, 0, and 5. And now I will select the correspondence. I'm going to say 2 corresponds to 0, 4 corresponds to 6, and -3 to 5 in the first set, in the first pair. In the second pair, I'm going to say 2 corresponds to 6, 4 corresponds to 6, and 3 corresponds to 0. -3 corresponds to 0. That's the relationship I created between these two in the second one. And the third one, I'm going to do this. 4 corresponds to 6 and also to 5. 2 corresponds to 0, and 3 corresponds to 0 as well. So the definition of a function says that each x value must correspond to one y value for this to be a function. Otherwise, it will be a relation. So obviously, each of the first sets corresponds to, or it's called domain. And how do we call the second set always? Very good. So their first set is always domain. And the second one is range. Domain and range. And of course, this corresponds to values of x. And this corresponds to values of y for all of them.